Hey there, here is a video explanation for answers for this first Check for Understanding written section. The first thing that you are kind of submitting to your teacher to check. In number one, for this figure, everything is true here. You just have to say why. So I'll just pause for a moment for you to pause it and double check that you've got what you should, and it agrees. In number two, there are many options for linear pair. The key word here is line in linear pair. If they make a line, then they are a linear pair, and they have to share a common side. So here's just one example. Angle BDF and FDA. BDF and FDA form a linear pair. Another way to recognize that is that DF here corresponds to FD here. So that means they share a side. Vertical angles are angles that are formed when two lines intersect at a point. And I like to think of vertical angles as making the V. So those vertical angles are a nice relationship in geometry. They end up being, I think you know this, they're congruent. So there's many of these here. Here's just one of them. Let's erase this part. A set of vertical angles in this diagram would be let's choose this one. Let's choose those two lines. Here's a set of vertical angles. And likewise, I'll put double arcs to show that those are vertical angles as well. Now when it comes to opposite rays, that part C, I believe there's only two. Double check my work, but I think there's only two opposite rays, because first they have to be rays. These elements here are segments. Those won't work. Opposite rays have to have a common endpoint, or common point, yeah, and go off in the opposite direction. So I see DC and CE. There's one. And then DF and DH going in that direction. I think that's it. Okay, part D, adjacent angles that do not form a linear pair. There's lots of options here too. Just got to make sure that you don't choose a linear pair by mistake. They've got to have a common side, but they can't form a straight line. So for example, let's see, I had a FDC, and CDA. They have a common side, but they don't make a straight line 180 degrees. I'll pause for a moment to give you a time to look at your statements here on number 3. I'll put that up. Then be careful on some of these on this number 4. Decimals are okay. This is math. It's going to happen. And so I think the key to start with here is realizing that vertical angles are congruent. Oh no, that's not going to work because you've got an X and a Y in there. You need to know that these two are a linear pair and they make 180 degrees. That helps you get X to be 31.5. Then you know that if this is 31.5, then its supplement is 148.5. So I think you've got to get X first in this case. For part B, the first thing to recognize is vertical angles here. So 50 is the same as 2x minus 16 degrees. That cracks open X, and then X is 33. Then you have to use that fact to make 3x minus y congruent or equal to it. X is 33, Y is 66. Okay, I made this video because in this final one, this is kind of your first proof. Want to make sure that you are in line, with kind of what geometrically we're thinking, and that you've got all the steps in there. I think most people got this part correct, where measure of angle 1 plus angle 2 is 180, and angle 1 plus angle 4 is 180. But then there's an intermediate step there called using the transitive property, that if two things are equal to the same thing, then you can just put those two pieces together. If A equals B and B equals C, then A equals C. That's where this comes from. And only then, when you subtract the something common on both sides, the measure of angle 1, then you have equality by subtraction for angle 2 and angle 4. Same thing happens when you want to prove that that angle 1 is congruent to angle 3. You've got to set them up with the transitive property, then subtract something common to get angle 1 congruent to angle